Good morning, students. Now, in this class, we are going to discuss what is meant by excitation and what is meant by excitation energy and also excitation potential. After that, we are going to discuss what are called ionization and ionization energy and potential. Ionization, potential energy. These things we want to discuss in this class. Okay. Right now we know that the energy of the nth orbit is given as En is equal to minus 13.6 into z square divided by n square. That is the energy of the nth orbit is given as En is equal to minus 13.6 into z square divided by n square electron volt. Here Z is the atomic number of the element considered and n is the principal quantum number. N is the principal quantum number. Suppose if we take hydrogen atom, for hydrogen atom Z is equal to 1. Therefore, energy of the electron in the nth orbit of the hydrogen atom is given as minus 13.6 divided by n square electron volt. Okay, we will know this. We have already discussed these things. When n is equal to 1, that is the electron is in the first orbit, means then the energy of the electron in the first orbit E1 is given as minus 13.6 divided by 1 square, that is minus 13.6 electron volt. Okay. Similarly, when n is equal to 2, E2, the energy of the electron in the second orbit, E2 is given as minus 13.6 divided by 2 square, that is minus 13.6 divided by 4, which is equal to minus 3.4. 3.4 electron volt. Similarly, when n is equal to 3, the energy of the electron in the third orbit, we know that minus 13.6 divided by 3 square, that is minus 13.6 divided by 9, which is minus 1.51 electron volt. And so on, we are able to find out the energy of any orbit of the hydrogen atom. Suppose the electron is in the infinity orbit, means then we know that E infinity is equal to minus 13.6 divided by infinity, which is equal to 0 electron volt. Then we know that the energy of the electron in the first orbit is least value. Therefore, this energy state is called as negatively larger value, therefore positively least value. Okay, therefore the energy of the first orbit is the least value, that is called as lower state energy or ground state energy. Then all other energy states are greater than that of this value, therefore they are called excited states. They are called excited states. Okay. Then we know that if we want to move an electron from a lower state energy to the higher state energy, what we want to do? We have to give an energy equal to the energy difference. That is, if we provide energy which is equal to del E, which is equal to that of the energy difference between the two states. Energy difference between the two states. That is, del E is equal to E2 minus E1, where E2 is the energy of the second orbit and E1 is the energy of the first orbit. Then right now, if we give energy which is equal to, for hydrogen atom, this del E is equal to, E2 is minus 3.4, then minus 3.4 minus E1 is equal to minus 13.6, therefore minus of minus 13.6, which is equal to minus of minus will become plus. Therefore, 13.6 minus 3.4, which is equal to 10.2 electron volt. 10.2 electron volt. Okay. Therefore, if we give energy which is equal to that of 10.2 electron volt, then the electron will move from the first orbit, that is ground state, to that of the next higher state. Ground state to the second state. Okay. Therefore, now when the electron is in the second orbit, instead of being in the first orbit, the electron is in the second orbit means then the atom is said to be in the excited state. Hydrogen atom is said to be in the excited state. Excited state. Therefore, this excited state is called as first excited state. First excited state. Then, to make the electron move from first orbit to the second orbit, the energy required is 10.2 electron volt. This 10.2 electron volt is called as first excitation energy of hydrogen atom. First excitation energy of the hydrogen atom. Similarly, we know that suppose if we give some more larger energy, what will happen? Suppose del E, the energy difference, which is equal to E3 minus E1 is supplied means, then what is the E3 value? Minus 1.51. Minus 1.51. 1.51 minus of minus 13.6, which is equal to 13.6 minus 1.51, which is 12.1 electron volt. 12.1 electron volt. Therefore, now when we provide this energy 12.1 electron volt to the hydrogen atom which is in the ground state, then absorbing this energy, the electron will jump from that of the first orbit to that of the third orbit. To that of the third orbit. Then now the atom is said to be in the second excited state. Second excited state. Okay. Therefore, 12.1 electron volt is the energy required to move the electron from the first orbit to the third orbit. That is called as second excitation energy. Second excitation energy. Okay. And also we are able to find out the third excitation. When the electron in the second orbit, that is called the first excited state. When the electron is in the third orbit, that is called a second excited state. Similarly, when the electron is in the third, fourth, fifth orbits respectively, they are called second excited state, third excited state, and fourth excited state, and so on. And so on. Okay. Therefore, right now, then what is meant by excitation energy? What is meant by excitation energy? Excitation energy is nothing but the energy required to make the ground state atom to excite into the higher state. Excite into the higher state. Okay. Therefore, here the excited states are many large number of excited states. First excited state, second excited state, third excited state, and so on. Okay. Then, right now, next, therefore, what is meant by excitation energy? If there is a question, then our answer is the energy required to excite an electron from lower energy state to any of the higher energy states.